Good evening, everyone. Myself Sridhar, and I am from CSC F section. And here for the data design and analysis of algorithm AAT Tech Talk. My topic is about MedSort algorithm. Then introduction to MedSort. MedSort is a popular comparison-based sorting algorithm that uses divide and conquer strategy. It efficiently sorts large datasets by breaking them into smaller parts. The algorithm was invented by John von Neumann in 1945 and is widely used in computer science. Here we can see that there is the method is a popular technique where we use in sorting the data, which is like in sorting them in ascending or descending orders. And also, I mean, sorting means arranging them in ascending or descending order, and it also efficiently used to sort a large data sets by breaking them into smaller parts. What is merge sort? Merge sort divides the input list into smaller sublists until each sublist contains one element. It then repeatedly merges sublists to produce sorted larger bits. The process continues until the entire list is sorted. Here we can see a sum list which is like 12, 8, 9, 3, level 5 and 4. Here we divide the by using the merge sort. We usually divide whole list into two equal parts. Here we divided the list of containing seven elements. We divided into three in one place and four in some other place. Here, then we further divide these elements into smaller parts. Then until it becomes a single piece. After it becoming a single element, then we sort them by taking two of them and started sorting them. Here we can see that all these elements become single elements, where 12 and 8 are sorted in a sorted order by taking comparing both of them. By this, we just sort every order or element in the list by you in the med sort, and this basically uses the divide on conquer technique, where we basically first divide the elements and then we conquer it by adding all this, and we get a sorted list. Here we can see that the divide and conquer strategy. The method follows the divide and conquer paradigm, breaking problems into manageable parts. The divide step split the list into halves recursively. The conquer step involves merging sorted halves to form a sorted whole. Here we can see, as I said in the before, the method is basically depend upon the divide and conquer strategy, where we firstly divide the list into smaller pieces of elements, such as if we have some elements, I mean like a list of elements, 8 elements, then we divide into 4 and 4. Then we further go and divide into 2 and 2, and then 1 and 1. So we can get an simple single element. So we can sort them, which is also known as conquering. In conquering step, we sort the element single, so that it's become easy to sort. Then how merge sort works. The algorithm first divides the list into halves using single elements list or obtain. It then merges these small lists in sorted manner. The merging process continues up the recursion stack until the entire list is sorted. Here we can see we just basically first we divide the list into the two halves, and then we divide the list until we get a single element. Then we start merging them and by in a sorted order, so that we get a sorted list. Detailed step-by-step process. Here, recursively split the uh, list into two halves until each sublist contains one element. Merge two sublist into single sorted list at each step. Repeat the merging process until the all sublists are combined. Here we can see we just divide all the list into the small equal parts, and then we get the elements, all the single elements. So we started sorting them. Merging process explained. Here merging involves comparing the smallest elements of each sublist. The smaller element is added to the new sorted list. This process continues until all elements from both lists are merged. Here is an example. We have in six elements where 5, 2, 4, 6, 1, 3. This is an unsorted list where the it is divided into two equal parts and the 3 and 3 elements, and then further divided into 2 and 2, and until it becomes a single element we divides the whole list. Here we can see the example where the considering the list 38 for 27 and 43, and which is like further divided into the smaller pieces and get then we just sort the list, and then we can see here that the example of the mud sort. As you can see here, the time complexity analysis of the merge sort. Here, the merge sort has a worst average and average case and the best case time complexity, which is a big O of n log n. This makes it efficient for larger data sets. The recursive splitting contributes to the logarithmic factor, while merging contributes to the linear factor. Here we can see the time complexity. The worst case time complexity of the merge sort is we go of n log n, and also the best case time complexity is also we go of n log n, and also the average case time complexity also the same, which is we go of n log n here, which is a better uh, time complexity for any sorting, for any sorting the sorting of any list. And then let we get analysis the space complexity of a merge sort. Merge sort requires additional space proportional to size of the list being sorted. This extra space is used for temporary sublist during merging. The space complexity is big of n, making it less suitable for memory constant environments. Here we can see that the space complexity of the merge is varied as a time complexity. Here the merge need more space as it required the divisions of all the elements. We are like dividing all the elements in the list, and then adding the merging those elements, so this need more space. As the level by level we are having some n complexity, so which is having the space complexity of big of n. And then advantages of merge sort. Metsort guarantees a consistent big of n log n performance. It is suitable, it is stable, meaning it preserves the original order of equal elements. It performs well on linked list and large data sets. Here the most important advantages of the Metsort is the time complexity of the Metsort. As the time complexity of the Metsort is big of n log n, where it is best for any sorting algorithm, uh, for any sorting of any list or any array. The it is n log n, big of n log n is the best time complexity, having a good performance, and also it is stable and also preserves its original list. Disadvantages of merge sort. Here there are many disadvantages, and also we're having some advantages along with some disadvantages. Metsort requires additional memory space for temporary arrays. Its recursive nature can lead to high call stack usage. It can be slower than in-place algorithms like quicksort or small datasets. Here, the main important disadvantage of the method is its time space complexity. It requires more space as we are like dividing it further and further, so it requires a more space. And then the practical application of merge sort. Here we can see the practical application of merge sort, where used in external sorting where data exceeds main memory capacity, employed in multi-thread and parallel algorithms, and also it is suitable for storing linked list and large databases. Then we can go for the variation of merge sort. In the variation of merge sorts, bottom up merge sort iteratively measures sublist without recursion, and also the parallel merge sort divides the data and sort parts concurrently. Natural merge sort takes advantages of existing order sequence in data. Here there are there are also some variations in the method, such as like bottom-up method, which is mostly used for the sublist which are without recursion, and also some parallel method divides the data, so it part concurrently, and also we have many variation in merge sort. Then summary. Here's a summary where the method is reliable, efficient sorting algorithm based on divide and conquer. Its consistent performance makes it suitable for large and complex data sets. Understanding its process helps in optimizing sorting tasks in various applications. And here we go with the references. Uh, there are some references where I got this PPT from. The common TH Darrison, the CE research, there's the book where the introduction to algorithms, and also the volume 3 of sorting and searching from Edison Wesley, the art of computer programming, and also here is rise of method in computer science articles and educational resources. Here, this is all about the method, and this is all about the method. Thank you.